All right, class. So this is our first lesson, and we're going to be looking at graphs and graphing utilities. So at the end of this lesson, you should be able to plot numbers on a number line. You should be able to evaluate algebraic statements. You should be able to graph equations of two variables on a Cartesian plane. And you should be able to identify intercepts from graphs in the Cartesian plane. So let's start with our sets of numbers. So numbers have a hierarchy, and you see here it says that a real number is a value of continuous quantity that can represent a distance along a line. Well, that doesn't seem like it means too much to us. What we really mean is that real numbers are everyday numbers. They're things that we use in our life. So we start with real, and this could be anything. This could be, 10, could be a million, or it could be a negative number, right? Like negative 15. Right, say we're reading a voltage or something and the voltage comes out negative, right? So there are negative numbers in everyday life. Then we've got real numbers split into two other things, which are rational and irrational. So rational are numbers that can basically be written as a fraction. And notice it says they can have no common factors, which just means it has to be in lowest form, or sometimes we'll say simplest form. So for instance, 2 is rational, right? Because 2 I could write as 10 over 5, for instance. 1/3 is also rational. Now, that might seem a little strange, but when we say rational, that includes fractions, which we could also write as a decimal, right? 1/3 is 0.3333 repeating, right? Just keeps on going. So that's rational because it's the same number forever, and it can be written as a fraction. There are decimals that can't be written as fractions, right? Something like, I don't know, 0.4572963, blah, blah, blah. Okay. That number should not be written as a, or if I've not written one that just happens to be a fraction, right? That shouldn't be able to be a fraction. Other things that are irrational that might be a little more on the line of what you're used to would be something like pi, right? Pi we know is 3.14192 something, something, something. That's an irrational number. There's the natural number e, that's 2.7 something. And it continues on forever. Things like square roots, right? Square root of 5, that's irrational. Then under rational, we have a couple more groups. The next is, let's see, integers. And these include basically whole numbers and what we would call negative whole numbers. So it could be like -3, 0, 10, right? These are all integers. Then that breaks down into whole numbers, which include 0, and then 1, 2, 3, 4, 5, and so on. And below whole numbers are natural numbers. And those are all of the whole numbers except 0. So sometimes we call them counting numbers, because when we count, we start with 1. All right, so that's the breakdown of all of the different types of numbers. So now let's look at a number line and how to plot numbers on a number line. All right, so the number line, right, just a straight line, and 0 we usually put in the middle. Then we have positive numbers on this side. And negative numbers this way. Remember, they go the opposite direction. Okay. Now, if we want to plot something as easy as -5, well, we just move to the left 5 units, and that's -5. We just put a little dot there. Something like 4.3, a little more difficult. We have to do a little bit of kind of guessing, right? We go over to 4.3. That's 3/10 of the way. So if we want to think of this as 10 little subdivisions, right, we could go about 1/3 approximately, right? 0.3 is a little less than 1/3. So 4.3 is going to be somewhere around there, let's say. And then finally, we can do 7/6. So first we need to know, what is 7/6? Well, if we put 7/6 into the calculator, it's approximately 1.16 repeating. So it's just a little bit more than 1. So we'll just come over here and put a dot just past 1. Okay. So when they're in between two whole numbers, you're just kind of giving a guess. It doesn't have to be perfect. Now, later on, we may use this for inequalities, where we're going to use brackets and parentheses. But for right now, just putting a dot for the numbers is all we need. All right, so let's continue on to the algebraic statements. So for an algebraic statement, we're going to have the sum of terms. And that just means that we've got a couple different things added together. So for instance, in this first problem, I've got x squared, right? That is a variable. And then I've got 17, which is a constant. Both of these are terms, right? So this technically has 2 terms. Now, what I'm going to be asked to do is to substitute 12 in for x. So in order to do that, I just need to plug 12 in wherever I see an x. And what I like to do is suggest that you put a set of parentheses where you see x. So I'm going to rewrite this expression. Instead of x squared plus 17, I'm going to rewrite it as a set of parentheses squared plus 17. And the reason for that is it's real easy then to say, okay, if x is 12, well, just write 12 in here. All right. And then we're going to go ahead and use our order of operations, which is PEMDAS, which you might remember. Remember, this stands for parentheses, exponentials, multiplication, division, which can be done in any order because they're kind of on the same, they're on the same level. In fact, division is just a type of multiplication, really. And then you have addition and subtraction, which again, now that one's a little tricky. You do have to work from typically left to right, but they should be able to be done in any order. And in fact, I'll actually show you some other things you could do to maybe quicken the way that you do these types of problems. So 12 squared, that's 144 plus 17. And then we're just going to add those together. So let's see, that's 154, 161. All right, let's try another one. We have 2x squared minus 3x minus 8. and they're asking us to plug in x equal -2. So again, everywhere I see an x, I'm going to put a set of parentheses, and I'm just going to rewrite the expression. So it looks like this. Then everywhere I have my set of parentheses, I'm plugging in a -2. Now you got to be a little careful, right, that it's a negative when you're doing your order of operations, but it shouldn't be too bad. So again, remember it's PEMDAS, so parentheses first. So inside the parentheses, I have a -2. Right? There's nothing I'm doing inside the parentheses here. It's just a number. So the next thing would be to treat the exponent. Now I have to be careful, and it's a really good thing to put the parentheses here, because even if you go to type it in your calculator, if you type -2 squared without the parentheses, it's going to tell you -4, because it's going to do 2 squared and then put a negative in front. If you put parentheses and then put the -2 in and square it, then you're going to get +4, which is the correct answer, because, right, -2 squared really means -2 times -2, and we know that a negative times a negative makes positive. Okay, so this is 2 times 4 minus 3 times -2 minus 8. All right, so 2 times 4, let's maybe just leave that in the parentheses. So 2 times 4, that's 8. Then we have -3 times a -2, that's +6. And then we have -8. Now you could do this left to right because it's all addition and subtraction. So you could do 8 plus 6 and then -8 and get 6. Or even easier, you could say, okay, it's all addition and subtraction now. I could do that in any order. I have a +8 and a -8. Those cancel out, and that gets me directly to 6. So these are little things that you might want to, kind of start wrapping your head around to help you when you get further along in mathematics, right? If you could do this step a little bit faster, then when it gets a little bit more complicated, then things start to be a little easier for you.